Hey guys, what's up? My name is Gabe and this is Games with Gabe. This is the next tutorial in the Coding Geometry Dash in Java series. So, if you remember from the last tutorial, we got to the point where we now have successful collision resolution, which means we can now play a level pretty easily. In this tutorial, what we're going to be doing is we're going to be adding the parallax backgrounds, which actually pose a little bit more of a problem than you might think. So, they're going to be moving at a different speed to the left as the player goes to the right. And then the other thing that makes these interesting is that they're infinite, which means that no matter how far the player goes, we will always have more background to continue going. This is achieved through a tiling effect with a little bit of magic with math. So let's look at how we're going to do this before we actually code it. I have a little diagram and we're going to see how this works. As you can see, I have this image with a bunch of rectangles and some weird squiggles and this green dotted line going around the edge that's right there. It's a little bit hard to see, but the rectangles represent background images that are tileable. So each one of these is one background image that are supposed to be the same. So it's supposed to be the same image, but just tiled going to the right. And then these bottom ones are the same thing, except they're for the ground and they're tiled to the right as well. And then the green dotted line is the viewport. That's what the player is currently seeing. So, as you might think, it's pretty easy to get the parallax background effect. We just move these background images to the left as the player moves, quote unquote, to the right. And these just continue to go to the left at a different speed than he is going. But what happens as these images move? As these images move to the left, we will want to have a new image appear to the right. So what we're going to have happen is once this image moves to the left and its right boundary right over here is even with this line, we will delete it or move this guy back around to the right side. And so that involves a little bit of a complex process because we have an array, and this array stores all the background images. So it stores I1, I2, I3, and each of those has their position. So what we do is we go through and then we check each one's X. So this is the first one's X, the second one's X is right here, and third one's X is here. We see which one is the greatest X, and then we say, okay, move this guy, his X, to the greatest X, which is over here, plus his width, which moves him right here. And then we basically pick him up, drop him right here, and he is no longer over on this side. But what that also means is we have to be very careful because we're using floating point numbers to store these transforms. So you can run into issues. What I was running into was there would be a little bit of a gap. So you'd have like a little bit, not this big, it'd be like a pixel or two, but it would be noticeable. And you'd have these gaps appearing between them. And the reason that was happening is because sometimes these were moving on a different time step. So while this one might be here right now, we might update this background, move him because he's already past the thing, and then this guy still can move within this frame. So then he ends up moving right here. And then we get a little bit of a pixel gap. So what we have to do to compensate for this is we also have to store which time step these things are on. And so the time step is simply, so the game updates one tick every few milliseconds, right? And so the time step is which tick are we on, which number tick. And we store these for each of the backgrounds. And then what we say is, okay, if this guy's time tick is 5 and this guy's time tick is 4, then what we want to do is we want to move him over to here like we did. But then what we want to do to make sure that we're aligned properly is we also want to subtract one time tick times the speed. So since we're moving at dt, which is the time tick, times the speed, what we do is we say, okay, we move him over to this X position minus that, and then that will correct for when he moves one more to the left. This is about the most complicated part when it comes to these background images. The other complicated part is drawing order. So we just want to make sure that we're drawing this image first, and then we're drawing this image because we have to actually draw a blue rectangle over this image so that they get a different color. But we'll see how all that works and stuff too once we actually start to code it. So that should be enough of the theory. Let's actually code this and see how it works. All right, so the first thing we're going to want to do is I have these two new folders, which will be available in a link in the description. And I'm going to go into the assets folder for our project and then copy and paste these just right into here. This will allow us to have access to these backgrounds. What they look like is just the different backgrounds in grayscale with some transparency so that they will take on whatever color is behind them. And these are the ground backgrounds too. So these are just the regular Geometry Dash backgrounds. Next, what we'll want to do is we'll want to go into our constants and set up a couple more constants that we will have to be using. So I'm going to go into here, and then I'm just going to go down here and say public static final color. This would be called BG color equals, and then I'm going to import that. And this guy's going to be kind of big, so he's going to be a new color 15.0f over 255. So this is just RGB, but I'm doing it in this format so that you can change it pretty easily. And then 98 over 255, and then 212 over 255. And that's the first color. And then we're going to add one more, and this is going to be color ground color. And this is going to be a new color. And I'm actually just going to copy this because it will make it a little bit easier. And paste it right here. And this one is going to be 2870 148. So we'll just change this to 28.0, and then this one to 70.0, and this one to 148.0. And then also, just in case, add in 1.0 for the alpha, just that these take on the proper alpha color too. So that's the constants that we will need. Now let's go into our level scene. So right up here, and we have this draw, and right now we're just filling the background as a white color. So let's remove this, and instead of that, we'll say constants.bg color. And then if we run this now, we should see a blue color pop up when we play the game. And as you can see, we get that blue color. So already we're getting close. Let's add one more constant too. I forgot about this one. So if we go back into here, let's add a constant, and this is going to be called player speed. So we're going to say final float player speed, and this is going to equal 395. Then we'll go into our rigid body class, and right here, instead of, or actually that's fine, we'll go into our level scene class right here, and then we will go to where we build the rigid body class for the player, which is up here. And instead of just doing that, we'll say constant.player speed. That way we can just use this constant whenever we're dealing with the parallax, because some of those will be bound to the player speed and kind of move according to the player speed. Next thing we'll want to do is we'll go into component, and let's add a new class, and this is going to be our parallax background. So these are going to be the backgrounds that we're using. This is going to, of course, extend component, and then we'll have to import this. So I'm going to say Alt Enter and then import that class. Then I'm just going to say implement those methods. So we get our copy and serialize. We don't have to worry about either of those because this is only going to be present in the level scene. If you did want to update this game in the future, then you probably would want to override these methods, because then you'd be adding this to your level editor so that you can actually pick which backgrounds you're using and stuff. And then you would need to serialize that data as well and then add it to your level scene. Let's add the private variables that we're going to need first. So we're going to have a width and a height, and that's just the width and the height of the background image we're using. We're going to have a sprite, that's just the sprite for the background image. Then we're going to have a public game object array, and this is going to be the background. So this is going to be that collection of backgrounds like I was saying, so that we can loop through them and everything. Next, we're going to have a time step. This is just so that we can keep track of which time step we are on. And then lastly, we're going to have a float variable speed, and that's going to be equal to 80. Or actually, yeah, and this is just like the speed of the slower backgrounds, and this is sort of the default speed I chose, and it works pretty good. Then we're going to have a reference to the ground object, so we will just add that in the ground component specifically. And then this boolean called follow ground. This is going to be used to differentiate between whether we're dealing with like a background or one of the ground backgrounds, which is the bottom pieces. Next, let's write a constructor that takes in all these variables. So we'll say parallax background, and it's going to need to take in a file. So this will get us the file, game object array, and this will be for the backgrounds that it contains. And then the ground object and the boolean, whether or not it is following the ground. And I will move this to the next line so that you can see that. So then we'll say this dot sprite equals asset pool dot get sprite, and then we'll give it the file Then we'll say this dot width equals this dot sprite dot width, and this dot height equals this dot sprite dot height. And we'll say this dot backgrounds equals backgrounds, this dot ground equals ground. And then we'll say if we're following the ground, so if we're doing the lower ground piece, then this dot speed equals constant dot player speed minus 35. And the reason that we're changing the speed for the ground, whoops, not equals, but minus. The reason we're changing the speed for the ground right here is because if the player's on the ground's going to be moving at the same speed as the player, whereas the background is going to be moving at a slower, more parallax style. So the ground moves same speed as the player, but we actually have to tweak a little bit so it's exactly the same. And then the background moves slowly to the left. Then we'll say this dot follow ground, not all caps, this dot follow ground equals follow ground. Next, let's do the update method. So we'll say override public void update. And this is going to do all those steps that I was really just talking about in the drawing. So basically, we're just going to increase the time step first of all. So say this dot time step plus plus. That means that for every tick, we add another time step so that we know which time step this specific background is on. Then we'll say this dot game object dot transform dot position dot x minus equals dt times speed. So then we just move it to the left by whatever the speed is. Then we'll say this dot game object dot transform dot position dot x equals float math dot floor this dot game object dot transform dot position dot x. And all this is doing is it's just locking it into an integer. And we do this just so that once again we get rid of those weird pixel boundaries. This helps with that. Then we'll say if the game object's transforms positions x is less than negative width. So if it is all the way outside of the boundaries of the screen and we can no longer see it, then we want to move it all the way back around to the right. So we'll say float maximum x equals 0. We're going to look for the max x among the other backgrounds. We're also going to say int other time step equals 0, and this is going to be the time step that the other background is on. Then we'll say for game object geo in backgrounds. We're going to say if the goes transforms positions x is greater than max x, then max x equals go.transform.position.x, and other time step equals go.getComponent parallax background dot class dot time step. So all this is doing is it's literally just a simple for loop looking for the maximum position. There's no special algorithm that I'm using for this. It's just search and find it. And then what we also do is we record what time step that parallax background is at so that we know if it's on the same time step as we are or not. Then we'll say if the other time step equals this dot time step. So if they are the same, we don't have to worry about decreasing it by the delta time. Say this dot game object dot transform dot position dot x equals max x plus width. Otherwise, else we do have to worry about the delta time. So we'll say this actually equals float math dot floor, and then we'll say max x plus width, just like we did before, except we're going to say minus dt times speed, just so that we compensate for that little pixel gap that could be appearing. And that should be it for the update method. So also, one more thing, if we're following the ground, we just want to make sure that the y position is always wherever the ground's y position is. So ground.gameObject.transform.position.y. So now the parallax background should be going right or to the left, but they should be going the right way. They should be going according to how they should be moving, and it should be infinite with that update method. Let's add in a draw method now so that we can actually draw them though. So we'll say draw, and this takes in a graphics 2D object. And we're going to say if we're following the ground, so if this is the ground piece, we'll just draw an image, this dot sprite dot image, and then we'll just draw it at this dot game object dot transform dot position dot x, this dot game object dot transform dot position dot y minus window dot get window dot current scene dot camera dot position dot x. And the reason we're doing the minus the camera is because we have to make sure that it's actually constrained to the screen, because these are actually world coordinates and this is just transforming it to a screen coordinate. Then we'll say the width, the height, and a null image observer. So the last parameter is just for that function. I'm going to scroll back over to here. Then we're going to say else. We're dealing with one of the background images, not the ground images. Say int height equals math.min int ground.gameObject.transform.position.y minus the window.getWindow.camera.position. Oops. .getCurrentScene.camera.position.y. This should really be a what's it called? Just like a window.getCamera, but we'll do that eventually. So what we're doing here is we're saying let's get the minimum, which is either the ground's y or the constant dot the screen height. And the reason we're doing this is because we want to, for the ground piece, actually draw over this little piece of background. So we have to draw over like wherever it starts and then just color in a different blue color. That way when we draw the actual ground piece, it looks different than when we're drawing the color for the background. Because if you play the game Geometry Dash, you'll notice that you have two different colors for each of those pieces. So we'll say g2 dot draw image, and then we're going to draw this dot sprite dot image, and then int this dot game object dot transform dot position dot x. We'll say int this dot game object transform dot position dot y, and then we're going to say width and constants dot screen height, and that should draw the image. And what's this going to say? And null. So don't forget that image observer. Then we'll say g2.setColor constants.ground color, and this is where we will draw that background image for the ground pieces. So we'll say int this gameObject.transform.position.x, and then we'll say height, because that's where we want it to start, which is where the ground piece is. Then we will say width and constants.screen height, and this will just make sure that it goes down far enough. So with all this done, that is about it for Parallax background. This should now be fully functional. What we need to do now is actually add all these Parallax backgrounds into the scene. So we'll go into our level scene, and then right below our init method, we will say right before we import init, and then we're going to say init backgrounds, and this will just be a method down here. It's just good to separate this from everything else, and we'll create this method which will initialize all of our backgrounds. So first of all, what I'm going to do is I'm going to move this whole creation of the ground. So I'm going to take this out and put it down here, and then take this out and also put this down here, because we actually do need a reference to the ground for the background. So we'll just have it down there. Next, what we're going to do is we're going to actually start coding this. So we're going to say the number of backgrounds that we're going to default have is 7, and that seems to be enough to cover the entire screen for me. So then we'll say game object in an array backgrounds equals a new game object array number of backgrounds, and that should have an S. Then we'll say game object ground backgrounds equals a new game object number of backgrounds. So we have two separate arrays for the two different types of backgrounds, the background and the ground backgrounds. And we initialize these arrays so that we can have the reference to the array, and it won't change. So we can pass these into the constructors and everything, and even if it's not full, the array, it will work. So that's a good thing about doing it this way. Then we'll say for integer I equals 0 until I is less than the number of backgrounds, I++. So we're just going to loop through. We're going to say parallax background bg equals a new parallax background. We're going to give it the assets / backgrounds / bgo1.png. And since this is a regular background, we're going to pass it the backgrounds, and we'll say the ground.getComponent ground.class, since it's expecting a ground component and it is not following the ground, so we'll say false. Then we'll say int x equals I times bg.sprite.width. This is just where is this background initially, and so we're just moving it according to how many backgrounds in we are. And then we'll say int y equals 0. Then we'll say game object go equals a new game object. We're just going to call this background, and it's a new transform with a new vector 2, and it's just going to take in our x and our y. Then we're going to need another function too. So we're going to say go.setUI true, which we don't have yet. So let's go into our render, or actually our game object first, and add this function. So if we go into game object right here, we're going to go up here and add in a private, well, actually public boolean is UI equals false initially, and then all the way down here we're just going to go public void set UI and then boolean val. So we'll say this dot is UI equals val. So this is just like sort of, you can set it or set it not. Then inside our render, we're going to add a little change to how we're rendering. Currently we're just automatically transforming everything, but if something is UI, we don't want to do that because they're being drawn specially. So what we'll say is, we'll actually say if g.isUI, then we will just say g.draw g2. Else we're going to do all of this stuff and draw it the special way, because if it's UI, we want to just draw it wherever it says to draw itself. We don't need to worry about transforming it because the transform means nothing for a UI object. That's the reason we're doing this. Now let's go back into our level scene and continue. So now we can set the UI to true. We'll say go.add component, the BG, so the background component, parallax. Then we'll say backgrounds I equals go. Next, we'll make the ground component, or the ground background. This is going to be a new parallax background, and we will take in the file. So assets slash back, I think it's ground bgs slash bg01.png. Let's just double check that real quick. I was completely wrong with that. It's actually grounds slash ground01.png. Then we'll do a comma, and I'm going to move to a new line for you guys. We will go the ground bgs, and then we'll give it the ground dot get component ground dot class, and then follow ground is true because this is a ground background. Then we'll say x equals I times ground bg dot sprite dot width. We're basically doing exactly the same thing we did up here, except this time we're doing it for the ground pieces. Then we'll say y equals bg dot sprite dot height, and this is this guy's height, because we're actually moving it down to the bottom of that guy. Then we'll say game object ground, game object equals a new game object, and we're just going to call this ground BG, and then this could be a new transform, new vector 2, x and y, so just like before. Then we'll say ground go.add component, ground BG, so the ground parallax background, then ground go.set UI to true, and then ground BG's I equals ground go, and then we'll say add both of these game objects. So we'll add the go, and then we'll add the ground, ground go. And that should be it. So we should have this initialized now. We've just basically put them all in their initial positions. They all know their speeds and everything, and it should just work. So let's run this and see what happens. So if I start playing, you can see that the ground just starts going up. The background is working fine, but not the ground. So let's see what's wrong with that. And I can immediately see in the draw method, when we're doing the Y, for some reason I did camera.position.x. That should be camera.position.y. That's probably why we have that really weird bug. Let's try this again. There we go. And as you can see, the ground and the background move right. But if you notice, there's this weird glitch. Why is this happening? Is something that you're probably asking. My suspicions are this is happening because we have no proper Z indexing. So what's happening is we added all the backgrounds first, then we added all the ground backgrounds, but the update order could be messed up. And so then we're actually drawing these first, then we're drawing this, which actually ends up drawing the background, the little rectangle over the image. So how can we fix this? Well, we add proper Z indexing. That's a little bit too long for this video though, so I'm going to save that for the next tutorial. You can also see effects of this too. If you look at the player, you can just barely see the transparency of the objects going over him. So you'll probably be able to see that better on your screen than you can on mine. But that's stuff we will fix in the next video when we talk about how to properly Z index, and we will modify our render to use that Z indexing value. So I hope you guys liked this. If you did, please hit like and subscribe, and I will see you next time. Thanks. See you.